So from the 70s to today, dam safety and fluid containment was the focus. Large volumes compelled increased diligence to ensure that tailings dams remain stable. And of course, we've been reminded of that in recent months through incidents in our neighboring province. Numerous techniques were employed. The rate of rise of hydraulic sand dike construction was limited to allow the pore pressure to dissipate from the sand structure. The observational approach was employed, which utilized extensive instrumentation, dosimeters, slope inclinometers, and so on, and data management systems to monitor the dike structure stability and to introduce mitigation measures where warranted. Specific dike foundation issues were dealt with. Potential static liquefaction was dealt with by using explosive densification of the sand, and weak foundation material, predominantly clearwater clay, required the construction of toe berms to flatten the overall slope of the dike structures. External review boards were set up to provide oversight of the data analysis and any introduced mitigation measures, and those are today a feature of all the operating mine sites. We also saw the increased involvement of regulators. The province of Alberta requires any structure used to contain fluids exceeding 3 meters in height to be licensed, and this includes all of the oil sand tailings dams. The Dam Safety Branch, previously under Alberta Environment, was the principal regulator responsible for ensuring public interests were being served. And in the 70s, it was decided that this responsibility would be shared by the then ERCB, now the Alberta Energy Regulator, AER. Operators continue to be required to submit detailed reports outlining the status of tailings dams. The 1980s to today, the beginnings of pit lake research. When it was recognized that oil sands tailings had unique properties compared to other tailings, research initiatives were undertaken by both Suncor and Syncrude, assisted by Natural Resources Canada and the Alberta Department of Energy. The Fine Tailings Consortium was created in 1989, focused solely on understanding fluid tailings. In 1995, the consortium finished its work, publishing a report entitled Advances in Oil Sand Tailings. And this book was known as the Silver Bullet. That terminology seems to resonate within the industry. It had 4 chapters, one on the Clark hot water extraction process and its tailings, fine tailings and process water reclamation, volume reduction of Clark hot water fine tailings, and a chapter on non-Clark extraction processes and their tailings characteristics. Volume 2 of the report, Fine Tailings and Process Water Reclamation, described water-capped fluid tailings reclamation. The report, based on early laboratory work, field studies, and computer modeling provided by Syncrude, concluded fine tails capping appears to be technically feasible. This led to increased efforts to develop fluid tailings, water-capped tailings technology. And there in the picture on the bottom right, you can see the small test ponds constructed in the late 80s and the 4-hectare demonstration pond constructed in 1993 and 1994. So water capping involves 25 years of research and development. The overall large picture shows a filling of the base mine lake, which occurred from 2005 to 2012. And that picture was taken in 2010. From the 1990s to today, CT technology, the silver bullet. Volume 2 of the report explored methods to reincorporate Clark hot water extraction fluid tailings back into stable soil deposits, leading to increased use of dry landscape reclamation alternatives. Based on earlier work by Syncrude and Suncor, referred to as spiking, the concept was to utilize the void space in the coarse sand tailings by combining fine tailings and sand with lime to create a non-segregating deposit. This technology was envisaged again as the silver bullet to manage the large volumes of fluid tailings that were accumulating. By 1995, there was a total of 500 million cubic meters of fluid tailings at the Suncor and Syncrude mine sites, and that number has since grown to about 1 billion with the additional mine openings. So CT, composite tailings, or sometimes called consolidated tailings, takes the whole tailings from the extraction process at about 45 to 50% weight percent solids, cyclones it to remove most of the water, and along with it that portion of fines, and then the underflow sand at something over 70 mass percent sand is used to formulate the CT. Mature fine tailings at about 30% solids, which would be generally over 95% fines, are harvested from the settling pond, mixed with the sand and with gypsum as a coagulant to prevent segregation. And this mixture is discharged into the settlement area, and that could either be in a beach above water format or in deep water, which has an influence on what happens, as we'll see.